Earth observation satellites are satellites specifically designed for Earth observation from orbit, similar to spy satellites but intended for non-military uses such as environmental monitoring, meteorology, map-making, etc. Most Earth observation satellites carry instruments that should be operated at a relatively low altitude. Altitudes below 500 to 600 kilometers are in general avoided, though, because of the significant air drag at such low altitudes, making frequent orbit reboost maneuvers necessary. The Earth observation satellites ERS-1, ERS-2 and Envisat of European Space Agency, as well as the MetOp spacecraft of EUMETSAT, are all operated at altitudes of about 800 kilometers. The PROBA-1, PROBA-2 and etc.Most spacecraft of European Space Agency are observing the Earth from an altitude of about 700 kilometers. The Earth observation satellites of UAE, DUBAISAT-1 and AMP, DUBAISAT-2 are also placed in low Earth orbits and providing satellite imagery of various parts of the Earth. To get global coverage with a low orbit, it must be a polar orbit, or nearly so. A low orbit will have an orbital period of roughly 100 minutes and the Earth will rotate around its polar axis with about 25 days between successive orbits, with the result that the ground track is shifted towards west with these 25 days in longitude. Most are in Sun-synchronous orbits. Spacecraft carrying instruments for which an altitude of 36,000 kilometers is suitable sometimes use a geostationary orbit. Such an orbit allows uninterrupted coverage of more than one-third of the Earth. 3 geostationary spacecraft at longitudes separated with 120 days can cover the whole Earth except the extreme polar regions. This type of orbit is mainly used for meteorological satellites. Herman Potocnik described the use of orbiting spacecraft for detailed peaceful and military observation of the ground and described how the special conditions of space could be useful for scientific experiments. The book described geostationary satellites and discussed communication between them and the ground using radio, but fell short of the idea of using satellites for mass broadcasting and as telecommunications relays. Weather. A weather satellite is a type of satellite that is primarily used to monitor the weather and climate of the Earth. These meteorological satellites, however, see more than clouds and cloud systems. City lights, fires, effects of pollution, auroras, sand and dust storms, snow cover, ice mapping, boundaries of ocean currents, energy flows, etc., are other types of environmental information collected using weather satellites. Weather satellite images helped in monitoring the volcanic ash cloud from Mount St. Helens and activity from other volcanoes such as Mount Etna. Smoke from fires in the western United States such as Colorado and Utah have also been monitored. The El Niño Southern Oscillation and its effects on weather are monitored daily from satellite images. The Antarctic ozone hole is mapped from weather satellite data. Collectively, weather satellites flown by the U.S., Europe, India, China, Russia, and Japan provide nearly continuous observations for a global weather watch, used via visible light and infrared rays of the electromagnetic spectrum. Environmental monitoring. Other environmental satellites can assist environmental monitoring by detecting changes in the Earth's vegetation, atmospheric trace gas content, sea state, ocean color, and ice fields. By monitoring vegetation changes over time, droughts can be monitored by comparing the current vegetation state to its long-term average. For example, the 2002 oil spill off the northwest coast of Spain was watched carefully by the European Envisat, which, though not a weather satellite, flies an instrument which can see changes in the sea surface. Anthropogenic emissions can be monitored by evaluating data of tropospheric NO2 and SO2. These types of satellites are almost always in sun-synchronous and frozen orbits. The sun-synchronous orbit is in general sufficiently close to polar to get the desired global coverage, while the relatively constant geometry to the Sun mostly is an advantage for the instruments. The frozen orbit is selected as this is the closest to a circular orbit that is possible in the gravitational field of the Earth. Mapping terrain can be mapped from space with the use of satellites such as RADARSAT-1 and TERRAS-RX.